Okay, example 6. A magazine reported that teenagers make an average of 15 minutes of outgoing calls. Wow, so much 15 minutes every day You all make 15 minutes outgoing calls now? No lah, I don't think you all do lah. Maybe 150 text messages per day maybe Right. Only 150, cannot be maybe, I don't know. I don't know how many? Ballpark. 200. Never mind. Okay lah, you won't tell me. Okay. Let's carry on. This magazine suspected. What is Denwa? Denwa is a name Denwa. Name Got such name Hey, cannot laugh at people's name. What if somebody in this LT has this thing right time? Got or not? Don't have lah. Better don't laugh at people's name. Sorry, I apologize first, okay? Sorry. Okay, anyway, she suspected it's not accurate. It means this is not accurate. She wanted to verify. Look, this is a population, and actually the sample size is small, n equals to 8. Look here. Summation x 86, summation x squared 1172. You want to test her suspicion whether it is 15 minutes or she thinks it's not 15 minutes. So do you think it's a one-tail test, two-tail test? One-tail or two-tail test? You think, talk to your neighbor. 10 seconds. One-tail or two-tail? Don't tell me, tell your neighbor. Don't tell me, tell your neighbor. Not accurate. That means it's 15, not 15. Two-tail test. Okay? Never mind. First, we find the unbiased estimate of the population mean. This is your x bar. Correct? This is the sample mean. Calculate. Thank you. Now, unbiased estimate of the population variance. This one, I think we've done it before. I'm going to do it very quickly. 1 over 8 minus 1. Then you substitute right? Substitute. Then you get 1172 minus 86 square of 8. Okay, and then you get 35. Because this is not required, I better round off to 5SF because I'm going to use this later. Okay? I'm going to use this later. 5SF. Now then we start our hypothesis test. Then we state. Let mu be the population mean. What is our H1, H0? Mu equals to 15. Just now you say it's a two-tail test, mu not equals to 15. Okay, now, look here now. Look at the difference between this and the previous 5 examples. It is the test statistic. That's why I insist that you need to write a test statistic. Because compare this with example 1 to 5. This now, your test statistic is your T. I would also like to emphasize that when you write T like that, this is uppercase X bar. This one is uppercase S. Now, I would like to contrast this big S, or big letter S, okay, with this S square that you calculated. Many of us may not understand. May have, but want to know, right? You want to know why so funny, why small letter and big letter so confusing? Thank you. Can I have attention, please? The reason is this. You have a population. This population. Then your n is so small. Right? Your n is so small. Now, whenever you pick 8 samples and then you calculate unbiased estimate, 8 samples calculate unbiased estimate, the S, this 35.357 is actually not a very good estimate for your population variance. It is actually a random variable. So far so good. It's actually a random variable. So that's why we say this is a t distribution. This is a random variable, this is a random variable, this is a t distribution. But when we do calculation, I want to find a point estimate of the unbiased estimate. I have no choice. I have to take 35.357. This is a point estimate. Just like x bar was a point estimate. 43/4, this is a point estimate. It's lowercase. It's a point estimate. Okay? Don't understand also, never mind, just remember uppercase. Okay? Okay? Never mind, you will soon understand, I'm quite sure. So now what's the difference between a t-test and a z-test? On the GC, no big difference. You just go and find the thing on the GC. Stat. Instead of doing your z-test, you take number 2, which is the t-test. Okay? You just do the t-test, and then you go to stat. This is 15. X bar is 43/4. 4, right? Yeah, correct. What is this? SX. This is your point estimate of the unbiased estimate of the population variance. Just now you calculated. Correct? 35.357. Wrong. Square root of it. Be careful. Yes, square root of it. Okay? N is 8. Two-tailed test, calculate. So let me explain. This will still be the p-value. You do decision making, you still based on your p-value. I need you to present this. Alright? And then it's bar 10.75. And that's it. The rest we will enter by you. What is this t value we talk about here? Remember? When we did our z-test, there was a standardized z value. You compare the standardized z value with a critical value z value, same thing. Your t also has a t value. Your t also have a corresponding critical t value. Later on, I will teach you how to calculate that. Follow? Okay? So, computation. Now, what do we need to present? The difference between z-test and t-test is I need you to show me that you know this degree of freedom. Must write, okay? Your x bar is 43/4, which is 10.75. You actually used your S value, the S value for, 35.357. By GC, you get a P value, which was 0.0829. Any questions? All okay? This is quite standard. Actually, you just use your GC to get. But maybe I would like to explain what is this negative 2.02160461, right, from the GC. I think most of us can get it already. In your Z test, you also have that Z equal. Just that in T, you have T equal. So I'm going to very briefly show you this diagram. You want to copy, I think better don't copy first, okay? Don't copy first, okay? Just look first, can? Don't copy, promise. Don't copy, can? Now, quick overview. This is your T distribution, which looks almost like a Z distribution. Correct? Mean is 0. Ayo, so messy. I don't show you. I draw on my own. Oh, easier. Later I show you this one. Okay. Okay, this is your T distribution. Okay, not symmetrical, but pardon me, okay? Correct? Where T is equals to X bar minus 15 over S over root 8. Correct? Where this is a random variable, this is a random variable. Correct? And my level of significance was 10%? Now, and look, I found out from my population, I found out from my sample here, n equals to 8, I realized that my X bar is 10.75 and my S square is 35.357. These are data. So actually I can calculate my little t is 10.75 minus 15. Is it 15? Yes. Divide by square root 35.357 divided by 8. Now, the calculator help you calculate this value, which is here. Follow so far? All understand? You don't believe you use your calculator to calculate now, you will get negative 2.0216046. Wait. What happened? Turn off by itself. Okay. By the way, talk about GC. Can you please? I think by now you all know your GC must charge. Before exam also must charge, okay? The night before, please charge. Okay? Right or not? Oh? Anyway, so what you got was a T value here. Sorry. This is T, minus 2.02. Remember, can you have attention? This is this. Can you have attention? Thank you. Now remember what is p-value? P-value is the probability of obtaining a value as extreme as the observed value. This is my observed value. So p-value is the probability of obtaining a value as extreme as the observed value. And in this case, because it's a two-tailed test, this area is my p-value. Follow? Because it's a two-tailed test, this is my p-value. Now, my challenge to you is, are you able to calculate p-value on your own without the GC? Actually can. You just need to find 2 times probability t smaller than minus 2.02. But this t distribution, must be very careful. This one has degree of freedom equals to 8 minus 1 equals to 7. Correct? Degree of freedom. Actually can. Let me show you. Now, in your second variable, when you calculate normal distribution, you had normal PDF, you had normal CDF, right? You also have TCDF. Look, number 6. Let's do 6. Lower limit minus infinity, upper limit, let's be a bit more precise, is 2.02 something. 2.02 what? You all know, right? 2.0 216. What is DF? DF is degree of freedom. We enter at 7. Okay, can? This degree of freedom is important because it takes there are different times 2 because I need the 2 area. What? Where? Oh, negative, daba. Silly me. Wait. Negative. Negative. Times 2. Yeah. You see this? This is exactly your p-value you got from your GC just now. Follow what I'm saying? Follow? So, let me go back to this. This is your p over 2. This is your p over 2. Correct? Just add them together, you get a p. Can? Then you compare your p against your level of significance, you're done. Okay? Then is there equivalent critical value? Let's say you do decision making. Is there a critical t value? Yes, there is. Do you know how to calculate? Inverse norm, inverse t, 0.05. To find out what is this? What is this critical value? Follow what I'm saying? Yes, I'm going to show. Then I will go back to this. You want to copy, don't want to copy, up to you lah. Actually, no need lah. Okay, you must know how to calculate your. Then you can. This is what I mean. Your rejection region is this. Inverse t 0.05, degree of freedom n minus 1. Can? You want to take a picture also can? I don't think I need you all to copy, but if you understand, you're good. At this point, can we wake our friends up? Only a few, I don't see a lot. Okay? Help your friends, can? If they're sleeping, help them. If they still say, hey, don't, I want to sleep, say, get out. Yeah, yes, that boy over there. 2, not just 1, 2. One person sleeping or 2 persons sleeping. The boy in blue, oh, okay, you're not sleeping. What are you doing? You in deep thought. You okay? Okay. Can you wake your friend up? He's constantly sleeping. What's your name? Yes, you. Don't look left and right. Sit up. What's your name? What's your name? Xiao Yang. You want to sleep? Can go to the library and sleep. Can I give you a chance? Really? All right. Conclusion. P-value. Since p-value is smaller than your level of significance, you reject. Now, can I bring your attention to the question? The question asks, you state any assumption made in testing, then one suspicion. Were there any assumption made? Let me bring you back here. It was this case that we use, correct? Sigma squared unknown. Nobody told you about variance. N was small, N was 8. Unknown 8. Now if X is normally distributed, then you have a T distribution. But if X is not normally distributed, out of syllabus, don't know. But was it mentioned in the question that the top time was normally distributed? No. So you better say. You better talk about the assumption. We assume that the talk time follows a normal distribution. Can we please answer in context for all stats questions? Please don't just say X. Just at least say that the talk time of outgoing calls follow a normal distribution.